down at the bottom of the page. Let me see, let's look at number 46. So page 114, number 46. Okay, g of x equals x cubed and e to the x. All right, now these are both functions that we are comfortable with. They're our BFFs. Hopefully, we're comfortable with those. So this is one big giant function, but it's in two pieces. You've seen these before, right? Okay, well, you're seeing one now. It's called a piecewise function, and we graph it in pieces. All right, so how does this work? Well, there are a couple of different ways to do it. But how I have found kids have the most success is just forget everything and look at y equals x cubed. Let's just look at the top line and just this much. Y equals x cubed. Now, do you know what y equals x cubed looks like? So I'm going to go ahead and draw y equals x cubed on my paper. There it is. I don't have to plot any points. I could, but I don't need to because I already know this shape. It's one of my BFFs I haven't memorized. Now, this is why we work in pencil, because now we're going to do a little erasing. Because I'm only supposed to be looking at what part of the graph. The only part of the graph that applies to this function is the part where x is less than or equal to 0. So that would be this part of the graph, right? So I'm going to take my handy dandy eraser and I'm going to erase this part because it doesn't apply in this problem. Does that make sense to you? So then I'm going to look at the bottom line. I'm going to do exactly the same thing. I'm going to say, okay, my equation is y equals e to the x. Now, do you remember what e to the x looks like? That's your exponential. I'm just going to go ahead and sketch it. It looks like this, right? And this is the point 0, 1. That's my exponential. But what? I'm not supposed to be looking at the whole thing. I'm only supposed to be looking at the part of the graph where x is bigger than 0. So there's an open dot there, just like on the number line. There's no or equal to, so it's an open dot. And I'm going to erase all of this because I'm not supposed to be looking at this. And there it is. There's your piecewise function. Now it looks weird, doesn't it? What would you tell me if I asked the question, what is the domain and range for this function? What would you tell me? What is my domain? All real numbers. Right here it is. Doesn't it tell you? X is everything. X is everything less than or equal to 0 and bigger than 0. That's everything. So your domain is everything. What's your range? Be careful. Sometimes we see this arrow and this arrow and think all real numbers, but not this time. What happened? We have a gap in the middle, don't we? So what's our range? Everything from 1 to infinity, or everything from negative infinity to 0, and the 0 is included. Okay, let's try another one. Let's try number 48. It's another piecewise function. I'm going to erase my domain and range. Everybody got domain and range? Okay, so let's look at 48. This time, we're graphing 1 over x and root x. Now again, you should be comfortable with these. These are two of your BFFs. You shouldn't be alarmed when you see those equations. Okay, do you remember what the top one looks like? What's the 1 over x look like? That's your reciprocal, that's your parabola, or hyperbolas, right? Your hyperbolas. So here it is, I'm just gonna sketch it in. Now, if you're thinking ahead and you're on top of all this, you know I sketched way too much, right? Because for that curve, I'm only interested in where x is less than 0, and that would be over here, right? So I want this piece, but I don't want that piece. So some of you probably just didn't even draw that piece because you're thinking ahead, and that's fine. If you're at all confused, just draw the whole picture and erase what you don't want. All right, what's this one look like? That one starts right here and goes like this. Now, I don't even need to worry about this time, do I? Because that's what I have already. That's all there is to that particular picture. So we're done. There it is. That's your piecewise function. Now, these guys, by their very nature, are usually discontinuous. Not always, but usually. And that makes sense, doesn't it? Because we're graphing it in pieces. So unless they happen to connect, you're going to have to lift your pencil. All right, let's talk domain and range here. What's your domain? Right here it is. This tells you about x. Your domain is all real numbers. What's your range?
All reals.
It's all reals this time, because while it looks like 0 is going to get skipped, if you look at this part of it, 0 is included here, so isn't every y value included? So this time, even though it's discontinuous, your range is all real numbers, just like your domain is. You okay with that? All right, I want to look at one more on this page. And that, or I guess there's 2 more. 51. Oh, I want to do 51 because it's in 3 parts. No big deal. You can have as many parts as you want. Oh, and notice, shoot, I just erased this one. But notice, I'm calling these piecewise functions because even though I'm graphing them in a wild and wacky way, do they pass the vertical line test? Yeah, they are indeed functions. So 51. This is our last practice problem. Let's make it good. Here we go. -3 minus x, 1, and x squared. And less than or equal to 0. 1 and greater than or equal to 1. All right, here we go. We're going to sketch this one. What in the world is that? That's a line, isn't it? Do you recognize that? What can you tell me about that line? The slope is -1, and the y-intercept is -3. So graph paper would be better, but I'm going to do my best. So I'm going to plot that point. That's -3, right? And then I have a slope of 1, or -1, I'm sorry, -1. It's supposed to be a straight line. We'll take it a little bit. So here is my line. Pretend that's a straight line, it's supposed to be. Is that okay with everybody? But I don't want the whole thing. What part of this line do I want? Where x, here's x is 0 right here. So I want this part and I don't want this part. So I'm going to erase that little part down there. This is the piece of the line I want because it's the piece where x's are less than 0. Remember, this is an equation here. This says y equals 1. What does that look like? Y equals 1. That's a nice little horizontal line that runs through just like this. Oh, missed. That runs through just like that. Now, what part of that line do I want? Do I want the whole thing? No, I only want the part from where x is 0 to where x is 1. So I only want that little piece right there, right? So the rest of this is gone. Y equals 1 is a horizontal line. You don't want the whole line, you only want the part of it that has x values between 0 and 1. Open on both ends because neither of those is included. Right? And then what's that? That's a parabola, and you can plot points if you want. I'm going to go ahead and sketch it. Oh, there we go. There's my parabola. What part of that do I want? Only the part of it where x is 1 or bigger. So I don't want this part. We can break our function up into as many pieces as we want. This one has 3 pieces. 2 of them happen to be connected. Domain? All reals. Right here's your domain. Haven't we included everything, kids? Domain is x. This is going to give you your domain every time. There they are, everything. What about your range? -3 to infinity. -3 to infinity. Every y value is covered starting at -3. One more on this page, but it's not a graph. 69A. Problem 69A. 7 of the 12 basic functions have the property that f of 0 equals 0. Now I picked this problem because I want you to always, always, always recognize that this notation gives you points, ordered pairs. If we say f of 3 equals 4, we mean the point 3 comma 4. And before you get confused, remember this is f of x. So x is 3. X is 0. Now what problem 69A is saying is that 7 of your functions contain this point. That means 7 of them go through the origin. Which 5 do not? Visualize. Which 5 of the 12 do not go through the origin? Can you think of any?
The inverse.
The reciprocal function, so I'll write the equation, y equal 1 over x, the reciprocal function. The logarithm function. The logistic function. Oh, anybody get that bonus right?
Yeah.
1 over 1 plus e to the negative x. Good, that's your logistic function. Cosine does not go through the origin. Remember, cosine is the one that starts up top, starts up here, hills and valleys, but it starts at the top. By the way, it's kind of dorky, and I don't think I shared it with you yesterday, but I got a cosine that looks like that and a sine that looks like this, right? The sine goes through the origin. So I remember original sin from my theology class. Sine goes through the origin. That's how I remember it. That's 36 years of teaching in a Catholic school. That's interdisciplinary right there. Okay, one more. There's one more. Exponential. The exponential does not go through the origin. Very, very good. I think you are doing great. You name those off pretty readily. Keep it up, keep it up, keep it up. I know it's a lot of information, but it will pay off to know those. Okay, now we have, I'm going to stop at 8:30 because I want to hand out your megaphones. So what are we going to do now? We are done. We have done everything in 1.3 completely. So we are going to start now with 1.4. Okay, so here we go with 1.4. Let me take a couple of functions. I'm just going to make these up. Okay, so there's just a couple of random functions totally made up. This one, of course, is a transformation of the identity. It's a line, but I've done some stuff to it. This one is a transformation of the quadratic, the squaring function. I've changed it a little bit by moving it, right? Now, we're not going to graph these. What we're going to do is some function operations. So if I said to you, what is f plus g? Do not make this hard. Just take a wild guess. You take both of them and add them. So if I did that and put it in descending order, it would be x squared plus 3x minus 2?
Plus 2.
Plus 2? Is that okay with everybody? And similarly, if I said f minus g, it would be, I'm going to go ahead and write this one out because I'm afraid I'll make another mistake. If I'm doing f minus g, I have to be careful to distribute my negative. So that'll be negative x squared plus 3x plus 4. Did I do that right?
Yeah.
That's easy. What if we had f times g? And in function land, we have to be very careful about how we write that. So we're either going to put f dot g like that, or we're going to put f times g like that. We are not going to put fg for multiplication. In function land, that has another meaning we'll talk about in a minute. So we want to do f times g. So that will be what? I'll have to do what then? I'll have to FOIL. So 3x cubed plus 3x squared minus 3x minus 3. Double check my arithmetic.
Yeah, I got that.
I tried to go in order. I don't. Is that right? I actually did FIOL just so things would be in descending order. Is that okay? And then we have, of course, division, which would be 3x plus 3 over x squared minus 1. Now, we have to spend a minute talking about this because in mathematics, domain is everything. Domain is huge. What's the domain of this linear function? All real. What's the domain of this quadratic function? All real. When I added them together, what was my domain? All reals. When I subtracted them, all reals. When I multiplied them, all reals. But now when I've divided them, my domain changes. My domain changes because now I have a fraction. And you remember my awesome video I made a week ago where we talked about issues with domain. When do we have issues with domain? When we have radicals and fractions. Those are the biggies. There are other little times like logarithms and stuff like that. But the biggies are, you got a radical, you got a problem, potentially. You have a fraction, you got a problem, potentially. What can you tell me about this domain? X cannot be 1 or -1. So my domain is everything from -infinity to -1, or from -1 to 1, or from 1 to infinity. Now think about it. You're telling me X cannot be -1 or 1. So X could be this, X could be this, or X could be this. Adding, multiplying, and subtracting did not change the domain because we didn't introduce any radicals or any fractions. As soon as you put a fraction in, now your domain is no longer all real numbers. You okay with that? All right. So, Betsy, you're in charge on, when did we decide I see you again? Not till Wednesday? Oh, we met in 5 days. So on Wednesday, remind me that we start with composition. Okay? Just say this is for composition. I would anticipate